Hopefully by now you've taken some time to do question number 7, check your answers to question number 7, and just kind of digest all that information. Because in question numbers 8 through 10, we're basically going to kind of take it one step further. Now that we know how to understand a sigma expression, we're going to do problems that involve that sigma. Namely, problems that involve finding the actual sum of the series that sigma is attempting to communicate to us. So in question number 8, it says find the sum of each series in number 7, which means to actually add 8 plus 11 plus until you get to 20. Now, when you're looking at this, you might look at that series of numbers, especially if you've made a table, and say to yourself, well, this is easy. Like, I'll just add 8 plus 11 is 19, plus 14, 33, and so on and so forth. And that is completely fine. But just to try to kind of exercise some of our practice judgment for a moment, I'm going to encourage you to try to practice using the finite arithmetic series formula that we came up with in the previous lesson, so that you can really kind of get that formula as often as you can into your lexicon, into your actual routine, so that it becomes easier to remember. In the long run, if you take Calculus BC, which is the more advanced of the two AP Calculus options we offer at Lacerna, there are going to be problems that involve you memorizing and using this formula. Now that's a long time away for many of us. It's probably a little premature to have to say to ourselves, oh my gosh, I should really panic and I should really memorize this thing right now. But it's kind of worth noting that practicing this formula and making it as easy to remember as possible is probably going to have some good long-term implications. It's kind of like memorizing the quadratic formula or the Pythagorean theorem. You've used it so many times since the day you've learned it that it's just probably easy to remember it, and you don't have to actually say to yourself like, oh, this is a quadratic formula problem, hold on, let me go Google that thing, or let me go look it up in my notes from 2 years ago. You don't need to do that. It's just easier to remember off the top of your head. So this formula is one where the more frequently you use it, the easier it is to remember. And I do recommend that you try to practice using it even on easy problems so that you have that access point in your brain. Now, of course, when I go back to page 8 and want to find the sum of the series in question number 7, letter A, I'm going to think about what I need from this formula. So I'm going to put my formula back here just so I can see it, and I'm going to think about this formula in the context of number 7A. I know that my formula needs 1/2 times a sub 1 plus a sub n. That's the first and the last term. First term is 8, 20 is the last term, so I know that. Then I need a sub n minus a sub 1, same numbers, 20 minus 1, divided by the adder. I already know the adder is 3 plus 1. Okay, so I have all those things. I like to quickly talk out my formulas before I write things down, just to make sure that I have the info that I need and I'm not just like, oh wait, crap, I need to do some side work or something like that. So let's kind of write it all out and let's make sure we're in good shape. I have 1/2 times a sub 1 from my question was 8 plus a sub n, the last term from my problem, was 20 times the same two values, 20 minus 8, divided by the adder. The adder was 3 plus 1. So just to kind of clean this up a little bit, I have 1/2 times 8 plus 20 is 28. And then I have a couple of steps here. 20 minus 8 would be 12. 12 divided by 3 is 4. 4 plus 1 is 5. So I have half of 28, which is 14. 14 times 5 is 70. So the sum of that series in number 7, letter A, must have been 70. Now, of course, you can always check if you want to by doing it the actual long way. You could do 8 plus 11, that's 19. 19 plus 14 is 33. 33 plus 17 is 50. And 50 plus 20 is 70. So you could definitely add it up. And if you want to, you can use that strategy instead of the formula. But like I said, this might be a helpful way of forcing your brain to interact with that formula and use it so that eventually you'll be able to remember it in the long run. If you don't use it much, it's going to be hard to remember it going forward. In any case, all of question number 8 is going to ask you to do that. So in theory, if you have tables, that's fine, but you might not even need them. You're probably going to notice that the formula that we've been using is wonderfully convenient because you really don't need to know a lot of the terms in between the starting and the ending point. You actually really only need the start and the end, the a sub 1 and a sub n, I've been calling them. So in letter B, think about the setup. I'll talk it through. I'm not going to write it down, but hopefully you can kind of see where I'm getting all this from. The formula is going to be 1/2, check, times a sub 1, that's 25, plus a sub n, that's 1. And then in the next bit of the expression, a sub n, 1, minus a sub 1, 25, divided by the adder. The adder appears to be negative 4, plus 1. It is worth noting in letter B the adder is negative 4 because it is subtracting by 4 each time we go through. And this is the first time that we've actually seen a subtracting pattern. So challenge yourself for a second to think about that idea that the adder is a negative number. Also, when you plug into this formula, a sub n is 1, the last term, minus a sub 1 is 25, the first term, and 1 minus 25 is negative 24. So think on that, chew on that. Is it going to matter that you have a negative difference on the top and a negative adder on the bottom? Or do you think conveniently that's probably going to work out for the best? You may also want to think about this series in letter B as if you really understand what's going on. Is it really different to say 25, 21, and so on and so forth with 1? Or could this series just as easily have been 1 plus and up to 21 and 25? Would it be the same numbers? Would the sum be the same if you wrote it from big to small as opposed to small to big? Chew on that for a second. If you get the formula, get the answer, and then want to extend your thinking a little bit. Those are not big important thoughts, so I wouldn't worry about it too much. It's just something to keep in mind if you want to kind of extend your thinking a little bit. So number 8 is just going to have you practice the formula in all of the problems that you've already seen. So practice using that arithmetic series formula. Question number 9 is also going to ask you to find the value of each series. And again, I'm going to encourage you to use the formula there too. Now, the challenge in question number 9 is that they're only giving you a sigma expression. They're not actually showing you all of the terms. So in question number 9, it might be helpful to think about what you need from the formula and then to kind of engineer a little bit of scratch work for yourself so that you know you're getting the most important stuff. For instance, in the formula, I need the first and the last term. That's not exactly being directly communicated to me from the sigma expression. Sigma tells me the initial, and it tells me the adder, but those are not part of the actual formula necessarily. I mean, the adder is, so that's great, but first and last, sigma's not telling me that. So this is where, as some scratch work or some side work, a little bit of critical thinking may come in handy. I know that this sigma wants me to begin with the 0 term and end with the 4th term. Those must be the first and the last that the arithmetic series formula is referring to. A sub 1 is the first term that they wanted me to add, and a sub n is the last term. So you can think of them in either way. I like to think of those a sub 1 and a sub n notations, but some people find that really confusing. So just call it first and last if you want to. Now, if you're looking at this going, darn, I have to write out this whole thing, you have a couple of options. I mean, one way is to think for yourself, well, 0, oh, that's the initial value, that's negative 1. But if you're confused and you're like, oh, but what about the 4th term? I don't want to have to do all the terms in between, 0, 1, 2, 3, 4. Remember, these are formulas. You can always plug in. If you're not sure what to do, think of 0 as an n value, and think of the term that you need as the t of n value, if it helps. In other words, I could take 0 and plug it into n, and I could just evaluate this expression the same way I do normal algebra. 2 times 0 is 0, and negative 1 plus 0 is negative 1. So I could just think of it that way if I wanted to. Now some of you are like, Herbert, duh, of course it's negative 1, I knew that. And that's great. If you already knew it was negative 1, you don't have to think about this. But notice how the plugging in strategy might save you some time. I don't really need term 1, term 2, term 3 in order to do this arithmetic series formula. I don't need them. They're not part of the formula. I just need first and last. So if I want to kind of cheat through this pattern and I don't feel like adding 2 and adding 2 and adding 2 and adding 2 according to the equation, I could just plug in 4 and quickly predict what the last term is going to be without needing all the terms in between. If I plug 4 into my arithmetic expression, I have 4 times 2, which is 8. Negative 1 plus 8 is 7. So now I know that my expression is going to involve plugging in a negative 1 for the first term and a 7 for the last term. Now, of course, you could definitely fill in the gaps if you want to. We know the adder is 2. Negative 1 plus 2 is 1, plus 2 is 3, plus 2 is 5, plus 2 is 7. It totally would have worked. But since I don't need those numbers, I want to be practical. Why would I do a bunch of calculations that I don't really need? Let's at least take some opportunities to shortcut things if possible. Now, let's do the formula. The formula is the important part because I need to find the value of the series, which is the sum of the series. And if you want to make that note to yourself, the value of a series is the sum, and the sum is really saying use the formula. Or add up all the numbers. It's not exactly impossible to add negative 1 plus 1 plus 3 plus 5 plus 7, but you can tell if you're taking this kind of shortcut approach and you're skipping all the middle terms, the formula is definitely more advantageous because if you don't know those middle terms or don't want to find them all, then the formula is going to be faster anyway. Let's do the formula. We have 1/2 times a sub 1, or first term, that's negative 1, plus a sub n, the last term, that's going to be 7, times a sub n, 7, minus a sub 1. Now minus negative 1 is going to become plus 1. I just need to remember that. Divided by the adder. The adder, according to my problem, was 2 plus 1. So there's my mathematical calculation that I need to do, and I can handle this with some mental math. I have 1/2 times negative 1 plus 7 is 6. Then I just have to be careful here. 7 minus negative 1 is 7 plus 1. 7 plus 1 is 8. 8 divided by 2 is 4. 4 plus 1 is 5. So I have 1/2 times 6 times 5, which is 1/2 times 30, and that would be 15. I'm doing this mental math. You can always use a calculator if you have any doubts, but that is the sum of the series. Now, of course, you can go back and check. If you wanted to do this the longer, slightly more tedious way, of course, you can just add these numbers. Negative 1 plus 1 is 0, plus 3 is 3, plus 5 is 8, plus 7 is 15. If that to you sounds easier, then definitely do it that way. There's certainly nothing to say that that's wrong, because it will work. The question is simply which way works for you. So in question number 9, that's basically what you're trying to do. You're going to try to use the formula by finding out what sigma is dictating is the first and the last term. And then once you know the first and the last term, just plug everything into your formula, evaluate your formula, you should be good to go. Question number 10 is just a multiple choice version of the same thing. So basically 9 and 10 are the same idea. As we finish up this series of videos, take some time to just make sure everything makes sense thus far. Take some time to make sure you understand how the formula fits into this big scheme of things, how to make sure that you understand what sigma is trying to communicate about the start and the stop values, and how to actually plug in numbers using your sigma expression as a guide. If you have any questions, don't hesitate to send me an email and ask. Or you can always leave a comment in our Google Classroom under the learning plan. Just specify which page or which question, and I'm sure either a classmate or I will see it and immediately be able to chime in. If you need anything beyond what the answer keys can provide, if you need work shown or something like that, also don't hesitate to ask. I've had some people in other classes who have actually asked me to record a specific video for one problem that I didn't necessarily post, and I'll be happy to record videos with me going over any of these specific problems if it would help shed some light on anything that you're working on that the answer key alone isn't helping with.